Waiting for my notification. Cool. All right, welcome everyone to the November 2023 Power BI and Data Analytics for Enviro's meetup. For those people that are new, welcome, especially. Great to have you on board and dialing into today's session. For some of our regular people on the call, always really nice to see you again, so thanks very much. Just our mission, in case you are sort of joining us for the first time, what we really try and do is create a virtual, global now with different presenters, virtual global experience where people can share some of the different experiences, largely using Power BI for environmental and water focused studies. So it's all about sharing information, learning new tips and tricks, and really empowering Enviros on their Power BI journey. So just a bit of housekeeping. I think we're all quite familiar with this, but just as a courtesy to today's presenter, please just make sure you mute yourself when not speaking. There will be opportunities to either write your questions in the chat, and there will be time both throughout the session. There will have a bit of a intermission, so to speak, between two different components of the presentation, but there'll also be a bit of a Q&A option or opportunity at the end of the session. So, yep. The session is being recorded, and as per usual, we'll make it available on our YouTube and blog afterwards. And yeah, just a little Teams tip: if you want to zoom into the content, you can hold Control and just zoom in with your mouse. I'd like to acknowledge the Bibbulmun people as the traditional owners of the land on which we are dialing in from today. Pay our respects to the wider Whadjuk people and their elders, both past and present, and also pay respects to the traditional owners and the Indigenous people from the lands that you're dialing in from here today as well. Just another little thing for this week, with the environmental focus, it's really important to always consider, recycling, waste generation. In case you didn't know, it's actually National Recycling Week. There's a link here to some of the great work that Planet Arc, who are driving this initiative and have been for, I think, 20, 30 years now, are doing, and also just some local events. I say local, selfishly, I'm in Perth in Western Australia, so some local events are happening this weekend in City of Fremantle Council and also City of Subiaco Council. But there's heaps more general events across Australia if you are interested to get involved and learn a little bit more about not just recycling, but obviously just waste segregation and the importance of sort of managing this in a sustainable manner moving forward. Discovery Eye, our company, just put on these meetups every month, just some of the work that we do. So Power BI largely training and also consulting and sort of working with a lot of water and environmental based companies to help really bring their data to life. So yeah, feel free to get in touch if you have any sort of questions regarding Power BI or environmental data visualization work. But on to the main event, which is why everyone's dialed in. We're very privileged, and thank you to Dr. Jason Hamer from dARTA, who's joined us today from Subiaco, so just across the river from where I'm dialing in from. And Jason today is going to be talking about largely a few different things, but the UWA sustainability dashboard, which if you've registered or you're obviously on the call, you might have seen the publicly available link, which looks really nice and it's got some great information there, which I'm quite looking forward to hearing about. But Jason's really going to cover off on both UWA's internal and external sustainability dashboards, but also some of the back-end architecture, a bit of the data sources and where this sort of information came from, as well as provide a bit of a background on his Power BI journey and some of his tips and tricks. So, Jason, without further ado, mate, I'll stop sharing. I'll put myself on mute and please, take it away.
Thank you very much. So I have selfishly kind of stolen my own profile from Christian because I wanted to give you a bit of a background of where I'm coming from, and I'll try and split the session into two so that there's a chance to ask some questions in the middle after I do a bit of demo of the content. But first, I would also like to acknowledge the traditional custodians of the land that we're in. I'm, along with Christian, on the Whadjuk Noongar people's land, and I acknowledge and respect their continuing culture and their contribution to the life they make in this region. And especially in this difficult time after the referendum, I will continue to seek and listen to their voice and seek their wisdom. I think it's still very important going forward. So who am I? there is supposed to be a lovely webcam image there that is live, so you can see me behind the shared screen, which has decided to fail today. There you go. I'm sure you can pull up my webcam if you want. So my background is actually as an environmental scientist. I spent a number of years studying through university here in WA and ended up doing a PhD in botany and climate science. So my passion is actually eucalypts. That was what my PhD was on. And I was assessing the vulnerability of eucalypt species to a changing climate in the southwest of WA. Spoiler alert, it's not looking good, but that's a completely different story. It turns out research wasn't really for me, though, because I was one of those weird botanists that filled a great niche, the niche of someone who wanted to sit in front of a computer and play with data. And that led me down a professional career because I didn't really want to move around the world fighting for 3 years of funding at a time. So I became a data professional. I worked for the university. First off, as a data analyst, and I progressed my career through data engineering, data scientist, being a data architect. I picked up all these skill sets in pursuit of a goal that I had for many years, and that was to be able to start my own business and take this skill set and give it to those who normally can't afford it. Here in WA, with a mining sector booming, the data skill set is really expensive. And it's difficult for the not-for-profit social enterprises and the startups to access that skill set because everyone charges through the roof. But I wanted to align my skill set with my values of sustainability and caring for country and people. And fortunately, after many years of developing that skill set, along with some of the top consultants in Australia, I'm finally here. I'm doing it. I've been doing it for 3 years now, actually coming on 4. And I love the work I do. I get to work with great businesses. I'm working with the Containers for Change guys at the moment, as well as UWA's sustainability team, some environmental consultancies. I'm across the board. It's a lot of fun. I get to jump across a lot of projects and make a difference. And I'm telling you this because I want to give you some context of where I've come from. Not only that I am an enviro myself, but more that my data experience is as a data professional in business intelligence. So what you're going to be seeing today is a bit more of the back end of how a good system is set up for a big business, and what I try and set up for other clients as well. And that's making sure that the foundations are done right. So when you come to Power BI, the work is easy. You don't have to worry about weird relationships or cleaning up the data in M or Power Query because the foundation has been done correctly. But I'll get into that a bit later. Bit of background on UWA as well, the University of Western Australia, for those of you who don't know. We are a group of 8 university. We're ranked in the top 100. We are a research-intensive university. I have spent many years involved with the uni in one way or another. We have one main campus shown here on the map, which is Crawley, and this is where my focus is going to be today. But there are other minor campuses scattered throughout Western Australia as well. In terms of data, the uni has tried a lot of different models, and I've been involved in the university's data teams in one way or another. And at the moment, they have a hybrid approach. So they have 2 central data teams, one that sits in IT that manages all the back-end stuff that has the data engineers, and one team that is filled with data analysts who try and service all of the broad UWA reporting. But it's hybrid in that there are scattered analysts across the university as well who don't live within those teams, but work off the same platform. And I was involved for 3 years in the data engineering team in IT to actually build the infrastructure for UWA's data platform. And I'll be showing you some of that a bit later on. So I particularly at the moment work with the sustainability team. and that is headed up by Geraldine, who I think may even be in this call at the moment. And I'm actually not going to spend too much time on what we're doing as a university for sustainability, because this is a Power BI group. I want to really jump through the Power BI stuff. But what you need to know is that sustainability currently sits under the campus management team, so it is very operational in nature. There are other teams in student services and HR that deal with other aspects of sustainability, but up until this point, sustainability has been very much environmental focused and focused on buildings and the grounds. We are looking to be carbon neutral by 2025, and we are on track to do that. And we are currently developing a sustainability strategy that hopefully should bring all these different aspects of sustainability together under one umbrella for the university. So as I mentioned, I've been involved with the university a long time. I've been involved with the sustainability team since 2019. I was actually working with them when I was at the uni in IT as a data scientist, developing a deep learning model, which again, I can show you a bit later on. Without any further ado, I'm just going to jump into a demo so I can show you what I've been working on and some of the cool things that we're discovering. So I'll send you this link so you can follow along. I'll pop it in the chat if I can find the chat again. Please hold. Nope.
I'm happy to do it, mate, if that
There
works.
we go. Gotcha. All right, so feel free to follow along with me. This is the link to our public sustainability dashboard. So I might just scroll out so you can kind of see the whole screen at once. Not the ideal viewing experience, but please feel free to jump in on your side and poke around as much as you want. This is all in Power BI, and it is embedded in the campus management website. So there are a number of different aspects that we're currently gathering data on and we're reporting. And as much as possible, we are making these data available online, freely available. We're not trying to hide anything. And there has never been a question of, should the data be available? Should we make it public? The answer is always yes. And the sustainability team is great for that because they realize that transparency and accountability is key for a sustainable journey. So I'm going to quickly show you through the public dashboard, and then I'll jump in and show you some different things in the internal. So let's have a look at energy first. So building consumption. This is a common view that you'll see in the public dashboard where I've got this map on the left. This is a custom shape file that I've created for the university that shows a heat map of where energy consumption is happening across the university. So energy, we are metering most buildings at the building level, if not more detailed. So fortunately, we can say that this big red one here, which is central plant, we know that that is the highest consumer, whereas we can have a look at some of our other residential colleges, the business school, and we can see how individual buildings compare. Now, why is central plant so high? Because this is kind of key to the whole story. So central plant is where the central chilling for the university happens. So for all of the aircon, we have a closed loop chilled water system that cycles water to each and every building across the campus for air conditioning purposes. So that sucks a lot of the energy up, but we can also distribute that energy to the buildings for reporting if we can also track the chilled water consumption by each building. So you will quite often see this little building here pop up as red. It is a big user. Some of the other big users, this one here is our Bayless building, which is one of our newer buildings for biochem. We have a couple of white buildings here as well, which is physics, which is normally a big one. This is a common story, unfortunately. It's one of our biggest battles in the sustainability team is meters going offline. Like, there is a massive network of metering across the university, and it's really hard to stay on top of. And sometimes building meters go down. We do have a team on the ground who can go around and fix that. Sometimes it's a software issue, like an IP changes. Somewhere it's a hardware issue. Sometimes it's a system issue in the cloud. Whatever it is, we try and fix it as soon as possible. But this is one of the great things that the Power BI reporting suite is good for, is identifying when meters go offline. Because historically, we've been using a Schneider building management system, which is great for operational usage. You can really drill in and see how fast that particular motor is spinning, or the temperature of the water going into that valve, how open that valve is, really detailed operational stuff. But from a reporting perspective, from a main user perspective, it's really hard to work with. It's really hard to get an oversight of the whole university and seeing what's happening. And that's where the sustainability team brought me on board, because they wanted to make all of this data centrally accessible to them and really easy to access, understand, and analyze. And so that is the primary objective of every report that I've generated for them, is not necessarily analysis, but in the first instance, just get the data out there. Because quite often I'm not the one doing the analysis, because there's smart people in the sustainability team, in campus management, who understand the system a lot better than I do. And if I can provide them the data in an easy to access way, it makes their life a lot easier. So we can see the peaks and troughs throughout the day. Looks like we've actually had some trouble with a few meters, because we're only pulling data since a couple of days ago. That's normally refreshed nightly. One of the main problems, with a couple of metrics on how well it's doing compared to other days, months, same month last year, and a historic profile. So this is a really common view that you're going to see across electrical, gas, mains, water. Some other interesting things, we do have EV charging on campus. We have 2 EV chargers at the moment. We try and make sure that our EV chargers are 100% offset by the solar on campus. However, when you have a look at the chart here, where yellow is our solar panels and blue is our EV, you can see that 50% of our EV charge is happening outside of solar periods. So we're only able to say that we're offsetting 50% of it. Why are there so many people charging their cars at 12 a.m. at night, 1, 2 a.m.? It's all of the taxi drivers, the Uber drivers that are loitering around and charging their car on campus while they wait for drives. So that was really interesting. And we actually have researchers who use these data that we provide them for their research on campus as well. In each of these, you'll be able to toggle between yesterday, 7 days, and 30 days as well, if you are interested. This one, a bit harder to read on 30 days. I did mention we had solar. So we have solar across 4 buildings, or 3 that are active at the moment, and a 4th that is still coming online. Everyone understands solar, so I won't delve too much there. That was electricity. Gas is an easy one, the same map, same view. We can see that our Bayless building, which is our big research institute, is a big user in gas. And we do have a really good spread of gas meters across the uni as well. So gas is used primarily for heating. So you'll see it peaking in June, July, August in the colder months. Thermal energy is one of the more interesting ones on campus and the harder one to explain. So thermal energy is chilled water. We use chilled water to cool the buildings and through the aircon. So that's what I'm talking about when I talk about thermal energy. Thermal energy meters are really expensive and hard to maintain, so we don't have as many buildings that are connected. And unfortunately, we have a few that we know are wrong. And that's, again, one of our big hurdles. Where our information is only good as the data that is coming through. And quite often that means that we have to delete periods of data, scale it, treat it differently. It's a bit of a nightmare when you've got a really massive network of old meters. The interesting view here is when we look at our thermal battery. So our thermal battery is a massive 2 megaliter tank on campus that stores chilled water. What that allows us to do is to charge the tank with our central plant during periods of high solar, so more renewable energy, or periods when it's cheaper for the university to do so, which is also tends to be high solar periods. And then use the tank chilled water to supply the campus during the big peaks, the really hot days. So it allows us to load shift is the term. And this is one way that we can save money and try and make our chilled water system a bit more sustainable. Here, the interesting chart is to look at the light blue line is the total load of the campus throughout the day. And then in dark blue, we have when the chilled water system, the set from central plant, is directly providing chilled water to the campus. Gold is when the thermal battery, the tank, is providing to the campus, and red is when the central plant is charging up the tank. So this is a bit hard to wrap your head around, but it essentially shows where chilled water is flowing around campus. And around 20% of our load at the moment comes via the tank. Obviously, that is higher in winter when there is less demand, and lower in summer, down to 10 to 12% in February and March. We can overlay this with temperature data as well. We pull in Bureau of Meteorology data, which is an interesting analysis as well. I'm really zooming through here because I kind of want to get through to the tips and tricks. Water, similar story. We have mains water metered across the campus. We also have groundwater. So this is our bore, which is used for our sprinkler systems and watering our gardens. Obviously, during the winter period, we don't use as much as during summer. And when you look at these charts, I keep getting really staggered by how much water we use every day. It just staggers me. I just can't help but feel sorry for our poor groundwater. But if this is just one big campus, and with all of the other houses around tapping into the bore, no wonder we have a problem. Waste. So waste is one of the trickier data to collect because we have a number of contracts with waste providers who provide us data quite often in PDFs. Have some of our project officers who scrape this data for me so that I can put it through our system. But we can break down where our waste is going from campus. The majority is general dry waste, which does go to landfill. But the next biggest is commingled containers. Now, this is actually mislabeled. I think this is just commingled recycling. But you will notice that there are a lot of other types here that we're all saying are diverted. And this is a tricky terminology here that I want to display better once we have better data. Diverted just means it doesn't go to landfill. Diverted can mean that it goes to an incinerator to create energy, which still isn't sustainable. We want to think about the circular economy. We want to be reducing, reusing. We want things to actually be recycled rather than just burnt as an alternative to going into landfill. So coming up soon, we're hoping to have more detail on this, and we're currently reviewing our waste contracts. So hopefully we can get some better data going forward. My personal favorite as an Enviro is looking at all of our tree data. So we have an arbor who comes on every year to review every one of our trees for safety, and they also collect a lot of data about our trees. So we can see, we can break down our tree canopy by species, by family, by genus. And this allows us to measure ourselves against that rule of thumb for urban forests, which is no more than 30% of trees should be of the same family. We fail that. No more than 20% of trees should be from any one genus. Check. And no more than 10% from the same species. We fail again. So this is a rule of thumb. And personally, I think for Western Australia, this is a really bad rule of thumb. Because as you can see, when we look by family, our biggest species are Agonis flexuosa, which is our peppermint tree, as well as eucalypt trees. So Corymbia, the Marri, we have Jarrah, marginata in here as well. So when we look at families, everything is Myrtaceae, but that's actually normal for the Southwest. So I don't see that as a problem. The land that UWA is on originally was probably predominantly Myrtaceae anyway. But it's really interesting drilling in here. We actually have this level of detail for the majority of our sites, and you can actually go in and find out information about each tree, which brings me to our significant trees page. So we have a lot of interesting trees on campus, and they have stories. So I like these ones down here. So next to a car park, these trees here, Acacia saligna, actually fed Trisha the elephant before she passed away in 2022. So we were donating branches from some of our local trees to the zoo to feed our beloved Trisha the elephant. We have trees that are planted by the Queen as well, somewhere around here. I can't remember where. And what we're wanting to do is create tree walks or across the campus for each of the different Noongar seasons so that we can guide self-guided tree walks so people can see and learn stories about the flowering trees, some of the significant trees on campus, and generally engage our community with our trees on campus. And canopy cover, very last but not least, we can use publicly available. This is from urban forest data by Department of Planning, Lands and Heritage. This is a WA only data set. We can see that we are 31% canopy coverage, which is great. Benchmarked against the surrounding suburbs and local government areas, we are above par. And we're actually similar to Kings Park, which is interesting. So Kings Park is the massive natural land that is just to the north of UWA. So that we're the same on tree height. So canopy coverage is reassuring. They have a lot more lower shrubs as well. So this is going to be your Banksia woodland. So this is natural habitat. So there's some interesting stories there as well. Again, apologies that I'm jumping through this so quick. That's the public dashboard. Please jump in, have a play. There's a lot of information there. The only other things I really want to quickly highlight, jumping over to our internal reporting, we do have the majority of what you've seen is what we present internally as well. We also do have our forecast. So this is actually what I was brought in for originally. And this was campus management wanting to understand the electricity load ahead of time so that they could plan, they could load shift with the thermal tank, turn things on and off. So they wanted to know when the peak was tomorrow and how big it was going to be. So this is a deep learning model that I created. It's for anyone interested, it's based on a long short-term memory deep learning model. And it pulls in things like weather, past behavior, expected attendance on campus, public holidays, as much information as I could. And it actually does really well. So on average, we're getting a mean absolute error of 5%, which is, we're off typically at the half-hour interval by 100 kilowatt hours, which is fantastic. And you can see how well it's been reporting earlier in the week. The gold is my prediction, and the blue is what actually happened. So we've been doing really well this week, which is reassuring. We had grand plans, but to automate some of the systems based on this forecast, but at the moment, a lot of the load shifting is still done manually. The only other thing I wanted to show you is, where are we? Anomaly detection. So this one's pretty cool. So because we meter, let's pick a building that has an online meter, shall we? Maths? Yes, cool. So because we meter at the building level, I can look at an individual day and I can benchmark it against other days. So the same weekday in the previous year, the same day type, so weekday versus weekend, same day type this month, next year, a lot of different benchmarks to see how well the building is performing on a daily level. So on the calendar on the left, we can see the red ones is where it's using more than we would expect it to. This here is a tool for the building managers and for campus management to go in and say, either we did an event this day, how much extra energy did it use? And I could say, oh, when did that event happen? 12 p.m. Oh yeah, there was a spike that was higher than normal, and we can measure that spike. Or a building manager can go in and say, oh, that's strange. Why on Tuesday the 17th were we so high? What was happening here? And this is one of the tools that the university is using to try and improve its efficiency, because we've done all the low-hanging fruit where we're replacing all of the lights. We're making sure that buildings are not leaking chilled air. But it's these stories here, like, what is this spike? Why did that happen? Where we can really get some interesting insights and make some improvements to our sustainability and our efficiency of energy. There is so much more I could delve into. We have a here it is, the missing meter report. So this is what campus management used to find all the meters that have gone offline or that are faulty. So this is really useful for the ground team to go in and fix these meters. That is a lot of information. And I want to leave it there because I want some time to delve into some of the tips and tricks, most of which I'm probably not going to be able to show. But I would just want to stop there and ask if there are any questions. I'll quickly look over at chat, maybe a couple of minutes, and there should be some time at the end for more questions as well.
Oh, that was awesome. Thanks so much, Jason. I think there was a lot of love in the chats. And yeah, sorry, I jumped in. Christian just got a phone call. I had a couple of personal questions just about the maps you used for like the electricity consumption and also that canopy cover. They look really neat and clean. What's the electricity consumption one? Is that like a map visual or is it a synoptic panel? Or?
Yeah, so this map here is using Power BI's standard out-of-the-box, what's it called? It's the shape map. So there's really nothing fancy here.
But with a custom background?
Yeah, so this is an image that's sitting behind. So there's an image and then there's a visual over top that I have aligned manually.
Oh, okay, cool.
Yeah. So the image I've created myself, so no copyright from Google, and all of the shape files I've mapped out myself as well. And every utility has a slightly different shapefile because sometimes two buildings are metered by the same meter, sometimes they aren't. So yeah, I'm just changing between which shapefile I use. The canopy coverage one. Oops. This one here is just an image because I couldn't get that level of data, unfortunately. I'd love it, but yeah, it wasn't downloadable. So it's just an image at this point.
Yeah, cool. No, I'm always interested in different mapping visuals. I think there are a couple other questions in the chat.
Yeah, handling water
Winds.
resets and drop-offs, big challenge. Agreed.
Yeah, the new Power BI update actually just got released today, and there is a really awesome slicer button, which I think if you haven't seen it yet, I think Wynn's saying you'll definitely love it. It means that we don't have to use so many bookmarks and things like that. You can do it in slices. So
Fantastic, yeah.
Maria had a question. That would be relatively static data? Is it done by the survey or using some sort of technology?
Depends which
I
data
think
you're
that was
talking
related to the maybe around the forest, like the tree coverage.
Yeah, so that is the canopy data is reasonably static. So it is updated throughout the year, but really there's 1 or 2 big surveys per year. So we just pull in the data manually when that happens.
Yeah.
We are hoping to expand our biodiversity data set. We're going to get some research students involved to survey the understory and some of the fauna on campus as well.
Yeah, awesome. And Maria's just got a follow-up question. Can you pivot any of the ALA, so Atlas of Living Australia data for biodiversity and canopy coverage?
Yeah, so a lot of the information that we get about our trees is coming from Florabase. It's all manually collected. I haven't looked at the Atlas of Living Australia. I remember it from my PhD days, but we haven't looked at it, no.
Yeah, cool. And I think one last question from Luana. There's more questions coming in. The long-term, short-term deep dive model, is that using a particular software?
So that is all coded in Python. And it sits in the back end on Databricks, which I'll show you in a moment. Is data collection from waste automated as well? No, that is very manual and very painful. We try, and I work with a few clients who try and get data out of the waste companies, and they just don't play ball. It's really hard to get data from them.
Tricky. There's always some manual component.
Yeah.
Awesome.
All right, I'm going to jump back
I think that's all
in.
good.
Oh, yes, cool. Right place. All right. Whew, I have a lot to get through, so I'm going to skip through some things and pick and choose some of the tips and tricks that I show you. So how is this being used? Mainly around engagement. We run hackathons, we've got digital billboards in work in progress. We run webinars like this. We're trying to make this data accessible and so that we can start conversations with our community. We also have teaching and research staff using it, and obviously operational as well. Clicky, there we go. So pulling in from a lot of data sources, using a lot of different techniques. Some are flat files like CSVs, JSON, some come from FTP sources online, some are REST APIs, some are direct database connections. So if you were to do this all in Power BI, it would be very tricky. This here, I'm not going to go into, but this is not necessarily how UWA does it, but it's how I would do it if I was starting fresh. So UWA was cutting edge when we first implemented it, but they've fallen a bit behind, as everyone does, unless you're a consultant and constantly get to change projects. But essentially what's happening is you have all of your source data on the left being ingested through Databricks. These are custom Python scripts that are connecting to the data sources and manipulating them, pulling the data and saving them to a bronze data store. UWA uses SQL database. I'm a fan of Snowflake these days. So Snowflake has our bronze area. dbt, I love dbt so much. I think it's going to revolutionize, or it is revolutionizing the data world. So it's coding SQL and making data modeling and data cleaning a lot easier and more accessible to non-nerdy Python developers. So it goes through a series of stages, bronze, silver, gold, as it gets cleaned up and modeled properly. A good model makes Power BI reporting a lot easier. And all of this is orchestrated. I'm a bit agnostic here. UWA uses Data Factory. I'm not going to delve any more in there. The semantic layer. So when I say Power BI loves model data, I'm talking about star schemas. And there is debate around, are star schemas still relevant these days? And I say, yes, they are. From a database perspective, maybe less so. But if you're in Power BI eats star schemas up for breakfast. So why are they so important? Star schemas are, very simply, a bunch of dimensions, which are your descriptors, things you can slice and dice by, and a fact table, which is your measurement. So a fact table here could be energy consumption, and it's measuring energy. And our dimensions could be about the building, about the campus, the date, the time, what meter it's referring to. And when you build it all up, you get lots of different facts. This is why it's called a star schema, because it has a nice star shape. But when you build it all up, it doesn't look like a star. But the power here is that all of our fact tables, despite talking about very different things, talk the same language. So when I'm talking about mains water and solar generation, two really weird things that you wouldn't overlay, but you can, because they're talking about the same building. They're talking about the same date and time on the same campus without having to draw a relationship between the fact tables. Because if you just had fact tables with all of the dimension information in them, so your standard sort of flat file that you would import from a CSV, your relations become a real mess and you risk getting circular relationships, which in Power BI are just going to break everything and be really hard to manage. So the power of the star schema is in those relationships and making sure that they're well documented, easy to use, and easy to understand. And I use what is called a semantic layer. So this is a data set in Power BI, which has all of my models in them, and all of my reports point to that same data set. So there's common DAX across them all. There's a single source of truth. So when I'm talking about energy consumption, I don't have multiple definitions, and it's easy to maintain in one place. I'm not going to show you what that looks like. I don't have time. I want to jump through some tips and tricks, because I think this is the really interesting stuff for all of you Power BI nerds out there, because I got some really niche things that will get you thinking. Date and time has been a big one. So when we're dealing with metering data, we quite often want to really drill in and see the peaks and troughs throughout the day. And this ideally is what I would like to see. I'd love to see two different variables, let's call them water and energy, overlaid with date time on the x-axis. Problem is, our star schema that Power BI loves means that date and time, where's my pointer? That date and time, here we are in different tables. So we don't actually have a date-time relationship. Now, what would be really lovely is if you could use a hierarchy and drill down from date down to time. That seems like it would work. And we can see this working if you just use the date from the date dimension. Yep, that checks out. They're all aligned. We've got a nice continuous x-axis. Works when we're just looking at time. So if I was to drill in and see, regardless of day throughout the time, if there are any peaks and troughs, I should point out this is all dummy data. Don't try and make sense of it. But when you put date and time from the two different dimensions together, Power BI is not smart enough to realize that the hierarchy that you've created is a date time. From your perspective, it is no different to the hierarchy that you'd get from a normal date time if you pull it in. You've got date, you've got hour, minute, second, month, year. But Power BI, when you pull in two separate variables from two separate tables into a hierarchy, will concatenate them as a string. This has caused me a lot of nightmare because you lose that continuous x-axis and things just don't line up anymore. You have to scroll. There's not equal space. Well, there is equal spaces between each data point, which aren't necessarily equal spaces in reality. Like these could be a whole day apart. but in the plot they're not. So this has caused me a lot of problems. And the solution is to have a date time dimension. But this has its own problems. So either you load every combination of date and time in the history of your data set, which for me is 3 years. So that'd be 95 million rows around about, which is way too big for a data set. So it doesn't take much to compute, but it does have massive storage. Option 2 is the other way around. You only load what you need, which uses a lot of compute, but has really minimal storage. So overall, this is how I feel about it. And I have tried talking to the Power BI community. I tried talking to Power BI, and no one wants to solve this problem for me. If you have a solution to this, please let me know. I've got a link somewhere that I can share. This is the discussion. I can post this in the chat. All this switching. It's a big problem because it is really hard to deal with a massive table like that. And I ended up using option 2, and that looks like getting each of your fact tables. Yeah.
Sorry, Jay, just jumping in. I think your screen might still be playing catch up on that one.
Oh.
Yep, I think you're back. All good, all good.
Oh, cool. Yeah, so I ended up having to get each of my fact tables, get a list of all the date times, and concatenate them into one single table, which is a stupid idea, but it's the only way that works. So that's something to keep in mind if you do star schemas with date times. Speaking of date times, when you're dealing with consumption data, there's something you have to keep in mind. So if we have a look on the right here on this table, actual consumption between 10:30 and 10:45 is logged at 10:45. Actual consumption 10:45 to 11 is logged at 11. But when you aggregate by the hour, that says it's 11 o'clock, but in reality, that consumption happened in the 10 o'clock aggregation. So this is something to keep in mind when you're dealing with data that are meters that aggregate over a period of time. If you're aggregating by the hour, you are not actually on the hour. So this becomes a real problem when you have 2 different meters that have different timestamps. So if one is metering every 5 minutes and one is metering every half hour, then the difference between them is going to be even bigger, because if I aggregate by 11 o'clock, in the 5 meter interval, I'm only missing one 5-minute increment. It's actually grabbing the 5-minute increment from the next hour, but the half-hour increment is a whole half-hour offset. So the solution here is to do date time minus 1 minute, because this forces all of the recorded date times to always be within the hour that consumption happened. Quick tip and trick. Big Power BI files. How much do I have? 10 minutes. I'm going to skip this one because I think automated documentation is fun. So this goes back to star schemas as well, and the semantic layer. So
Are you still there, Jason? You might have just lost him. Just give him a chance
understand the relationships between the tables. So
sorry, you're back.
Okay.
I think you might have just froze for one
Oh,
moment, but
yeah,
you're back now. It's all good.
A Teams call. Strange.
All good.
So
No
the
worries.
problem with the semantic layer is you can't see the detail that is in the master data set in your report that you're generating on. So what I do is I use Tabular Editor to run C# scripts against the Power BI file to automate some of my documentation. So for example, in my master data set, I have all of these different measures And normally you can't see how they're calculated. But if you put the DAX into the description, it means that the report user, the report developer can view that DAX without having to look in the master data set. So that's really useful. And I'm happy to share this little snippet here as well. Give me a moment as I switch screens again. So this is a little C# snippet that will simply take the description of the DAX measure and set it to the expression. Very simple. What gets even cooler is when you, come on, here we go, is when you document all the relationships on the table in the description. This is really powerful for fact tables, because quite often, for example, this is a fact table that has a lot of different foreign keys, and they are using the same dimension multiple times. So you have to know which relationships are active and inactive. And that's really important for the developer to know. But they don't want to have to dig in and try and find those relationships. So here I use a C# script to document and automate the population of this description with all of that information that's needed. And even cooler again is you can still have the description of the table up the top here. And all I'm updating is the bit after this line break. So I think that's really cool. And it's starting to think about how you can automate some of the documentation in your master data set. Web integration. So the public portal that you saw didn't have the usual iframe embed stuff in it, which I think looks really ugly, and generally you're probably not interested. You don't want the end users to see all of the like Microsoft social stuff, and I didn't have pages for you to flip through. I wanted you to interact with it. So how did I get rid of it? Yeah, I mentioned that this was an iframe because, and we chose this actually as a proof of concept at first, but it did the job, embedding Power BI into the web. So we decided not to go down the route of getting web developers in to develop it from scratch. We're not on premium capacity, so we couldn't use Power BI Embed. It's stupidly expensive. So iframes worked well, but I needed to get rid of all this junk. So this is what I did. So any of you who understand HTML, or even if you don't, you can save this for later. If you have a div which contains your iframe, you can set overflow to hidden. And then in the iframe itself, you can make the iframe bigger than the div, so it overflows the div. But because the overflow is hidden, I can then adjust this a bit to the left, a bit to the top, and all of a sudden you can't see all of the extra UI stuff. It's still there, it's just hidden behind the div. So that's something cool to keep in mind. I had more tips, would love to share them. Maybe I'll have to come back another time, but I want to wrap up there so there's a little time for questions the last 5 minutes. So where to, engagement is still key. This is a lovely photo of some of us from the sustainability team up at the Gravity Discovery Center, which is actually one of UWA's satellite campuses. And we get to see some pretty cool stuff that normal public wouldn't be able to see. So that was fun. And we're trying to be very data driven with our sustainability and our strategy. So as we develop our sustainability strategy, we're trying to bring in more data from a broader breadth of sustainability aspects from the university and bring it under one umbrella. 5 minutes to go. I want to leave it there so I can take some questions. Let me.
Jason, that was brilliant. That was I think those range of tips and tricks were just fantastic. I love the little HTML hack as well, like for the changing the iframe embed link. That's fantastic. But mate, like we really appreciate what you've presented today, and definitely get you on at another point, because there's obviously so much to, that report, that project, and it's still ever growing, obviously. So no, mate, that's fantastic. Thank you. We did have just a few questions. So Win actually posted a photo from a demo file of a chart trying to see if this was what was needed for the date time problem that you were mentioning.
So the problem with that is it's not a continuous axis.
Yeah.
So you would then have to scroll if you have multiple days, multiple months of data on that. You would need to have a scroll bar on the bottom, which doesn't look really good. I want to be able to cram everything into one horizontal view. But it's close, but yeah, not quite.
Yeah, the categorical versus the continuous x-axis, and yeah, removing that scroll bar makes sense. Yeah, and it is a challenge. I don't know like how you do it. I mean, when you're dealing with such fine sort of time scale of data, it is extremely challenging. So no, you've done very well in terms of what you've been able to produce. There's another comment, lots of love in the chat. I know you're probably seeing all of those. Thank you everyone for writing your positive comments and also for your questions and discussions during the session. Are you still there, Jason? We might have lost Jason. Yeah, thanks everyone. Hopefully he comes back. Yeah, Alice, to your point, probably a good idea maybe with your involvement in the Power BI Core Visuals team to mention that one.
Come on.
You're back. I think we can hear you.
Come
on. Otherwise, while Jason's just trying to come back, and I might just share screens quickly, and hopefully I'm coming through clear to everyone. But yep, as per normal, we'll put up the recording and the session from today, probably early next week. We've still got one more session in 2023 in December. I'm still trying to find a speaker, so if anyone's keen to share their experiences in the Power BI and environmental world, beginner, advanced, new users, it doesn't matter. It's just all about sharing knowledge, skills, and, much like this session, just having a conversation about Power BI and environmental based data and some of the challenges, sharing tips and tricks. But feel free to hit me up. Otherwise, we're going to kickstart into next year, which is very exciting. And thank you all for attending. It was, lovely to see some of the regulars, and to anyone that's new, thank you very much. The other thing that I'll just raise, and Win flagged it during the session, is this morning, our time, the release of the new feature, or the new update, sorry. So go and have a look. There's some really exciting things from a visualization perspective. So feel free to jump in, go and have a bit of a look around. And I think there's a few people over the past week that have been starting to play with some of these features as they start to get rolled in before the actual blog and video get released. But yeah, that hit our screens on the blog earlier this morning. So I think this is the one that a lot of what Jason has created through the nice use of slices, images, bookmarks, buttons, that combination. I believe a lot of it can be achieved with this one, which has been getting a lot of love. And I think also from a visualizations perspective, this reference labels is also quite cool in terms of what used to be, largely multi-row card. We can now bring so much more information in a much more clear, concise way rather than having to scroll through in a bit of a tabular-based view of something like this. But I think it's just the start. I'm looking forward to exploring it, when I get a chance. But I think we have actually lost Jason, which is unfortunate. But thank you all for your great comments. And I will stop the recording. I'm happy to stay online for another 5 minutes or so. I might just give Jason a separate call on the mobile. But yeah, I'll stop the recording, and thanks everyone. Enjoy the rest of your days.